Alright, welcome back to another video. Today's got a big title. Looks like integer exponents, scientific notation, and order. As I was saying, order of operations. See, I made a mistake. Mistakes are okay. I fixed it. That's what you do with them. Alright, few rules of exponents here. First of all, anything to the 0 power is 1. I mean anything. You know, if you have even like a 7 to the 0 power, it's 1. If you have n to the 0 power, it's 1. Anything to the 0 power is 1. I will show you why that is true in class tomorrow. Negative exponents. When you have a negative exponent, it means you flip where it is. Either put it from the numerator to the denominator or denominator to numerator to make it positive. They're going to make you make things positive. So if you have something like this, 4 to the negative 3, you must take it to the denominator, make it 1 over 4 cubed. If you had two situations where you had, let's say, a to the negative 2, b to the negative 3, you would just flip it, make the exponents positive, and you're good to go. Nothing on the slide. Okay, write each of the following with positive exponents. So this first one, you just need to take it to the denominator, make that exponent positive. The second one, since it's in the denominator already, you would move it to the numerator, make it 0.82 to the 7th power. And the last one, you would switch both of them, y to the 8th over x cubed. And that's all you got to do on those. Properties of exponents. There are like 6 or 7 properties right here. The first one, when you multiply the same base, now notice all these properties, these first 3, all have the same base. They're both a's. When you have the same base and you're multiplying, you actually just add your exponents. When you do that, you did multiply. People forget that sometimes. If you have 2 cubed times 2 squared, you get 2 to the 5th, not 4 to the 5th. When you add the exponents, you did do the multiplication. So it should make sense then if you divide the same base, you subtract the exponents. You do just the opposite of multiplication. When you have a power, one exponent raised to another exponent, that's when you multiply the exponents. It's called the power rule. When you have a parentheses with an exponent outside the parentheses, it applies to everything inside. If they're multiplied together, it's called the product to a power. You raise both of them to the same power. If there's a fraction inside, which is really division, you raise the numerator and denominator to the same power. But look at a couple examples here on the next slide. The first one, part A right here, has 2 y's, same base, that are multiplied together. You just add the exponents, you get y to the negative 2. They would not let you leave a negative exponent in an answer. Just go ahead and take it to the denominator. Part B, start with your coefficients. 48 divided by 16 is 3. And because it's division, we're going to subtract our exponents. 12 minus 4 is 8, and that's all you have to do to divide. Now, I will say this. If the 12 would have been in the denominator and the 4 in the numerator, we would have left the x in the denominator. Part C, power to a power here. When you raise one exponent to another one, you multiply the exponents. So look what that gives me. It gives me a negative exponent, which means you must take it to the denominator. Part D, the 5 is outside the parentheses. It's a product, which means it applies to everything inside the parentheses. So I'm going to raise 2 to the 5th power. S already has a negative 2, and because you're raising one power to another one, you're going to multiply those exponents. Now look what I have here. I have 2 to the 5th power, which is positive, s to the negative 10 power, which is negative. So that means I must take the s to the denominator. I'm going to go ahead and work out 2 to the 5th also. 2 to the 5th is 32. And when I take s down here, the 10 becomes positive, which is what I wanted. Okay, E looks like a doozy. I'm even going to change colors for it. I'm going to work inside my parentheses first. 45 divided by 9 is 5. I'm going to go ahead, the x is negative. I'm going to take it down here. The z is negative. I'm going to take it up here. The y is positive, so I'm going to leave it here. And I have a negative 3 out here. Now, I might have jumped the gun right there. The negative 3, because it's outside, applies to everything inside, which means it applies to the 5, the y, the z, and notice I'm multiplying because I'm raising a power to a power, and also the x. Now once again, they're not going to let you leave negative exponents in your answer, so basically I'm flipping everything right here. I'm taking the x to the numerator, and it'll be by itself because everything in the numerator has a negative exponent. So 5 cubed, y to the 6th, z to the 24th, all come to your denominator. Now, I'd probably go ahead and work out 5 cubed. I'm out of room here to make it 125, and that would be absolutely fine. So, to be honest, I probably jumped the gun on that one. Probably should have gone ahead and raised everything to the negative 3 power when I started, and that way it might have been a little quicker, but either way is fine. Scientific notation, I know you've seen this before. It's just a great way to express a very, very large number, a very, very small number. What you need to know about it is the number that you put here, the n, has to be a number between 1 and 10. It can have a decimal with it, usually will. Your exponent has to be an integer. It can be positive or negative depending if it's a big number or small number. And you've seen this before. Directions here are going to say convert it back to a decimal. So there's a number really very small because it's got a -4. What the -4 tells you to do is move the decimal back to the left 4 spots or 4 place values. So I'm going to end up putting 3 zeros, then 7, 6, 3, 2. So I'll move the decimal. Originally the decimal was right here and moved it to the left 4 places because the exponent was negative. Okay, next one, the exponent is positive, which means I'm going to take this exponent and go move it 5 places to the right. So once I move the 4, that's 1, 2, 3, 4, 5. So that number represents 940,000. Okay, the last thing today is order of operations. And again, I know you've seen this before, or at least you should have. Just review really quick. Always do within the grouping symbols first before you go outside. When you have more than one grouping symbol, go from the inside out. Next, we're going to do all the exponents or powers. Then we're going multiplication and division from left to right. Then, of course, last, we're going to go addition, subtractions from left to right. People tell me all the time they do please excuse my dear Aunt Sally, and that's fine. PEMDAS, whatever you've learned it by, as long as it works, I'm good with that. Let's look at one example and we'll be done. Pick the doozy here. One thing you need to know about this problem and all fraction problems that you see, the fraction bar is a grouping symbol. People don't realize that, but the fraction bar is a grouping symbol. I also have a parentheses in the numerator, so I'm going to do that part first. 10 divided by 2 plus 9 times 4 over 2 to the 5th plus 3 squared. Now, because I have a fraction bar, I have to work out to simplify the whole numerator and the whole denominator before I divide. So in my denominator, I see 2 exponents. 2 to the 5th is 32. 3 squared is 9. In my numerator, I have division and multiplication. Do those left to right. 10 divided by 2 is 5. Do not do the addition next. You go ahead and do the multiplication because you do all multiplication and division before you add or subtract. My numerator now looks like it's 41. My denominator also looks like it's 41. How sweet is that? So your final solution is just 1. All right, hope that wasn't too bad. A lot of stuff thrown at you there pretty quickly. We will go over it again in class tomorrow and do a bunch of the assignments, so look forward to seeing you then.